started. So let me get started with the our course. Oh, this is stupid. Our course. So this is the basic stat for required class for all B school major. So whether you like it or not, there's no escape. The only escape is for me, but you'll be captured by other instructor anyway. Actually, when I was 10 years ago, when I was undergraduate student like you, I do study this course, but like 10 years ago, we have this class divided into 2 semesters. So it's 4 credits for 2 semesters. Now we have 4 credits for 1 semester. So it means that things are more condensed and will be more difficult. But I guess we know these days everyone is very busy. Unlike 20 years ago, like me, nothing to do. I mean, there's no phone there at that time. So we would make it more application oriented. Okay, so to make sure that it's still manageable for you to finish. But do note that our course is 4 credits, right? So you expect to spend 1/3 more than other class, right? So to start, I mean, let me introduce myself. I'm Chiu Yu. I got my undergrad in B school, and then I got my master in the econ department, and eventually got a Ph.D. in US. Then when after I graduate, then I taught in Singapore. And during the pandemic, I come back, and this is the 4th year I taught this class. So I have been teaching this a lot of time already in Hong Kong, and also when I was in US doing my doctoral degree, I do teach a similar class as well. So I think I'm pretty experienced in terms of teaching the introductory statistics. Oh, here this old version outline that our TA is not TBA is already finalized. Who is sitting at the back? So you will say hi to him because he will handle most of your assessment. And in case you have any question or issues, please email our TA first. If he's unable to do it, then he'll refer you to me. And of course, now compared to 10 years ago, in my old days, I mean, we're looking for solutions very difficult, right? And now internet is very easy. AI is also making things much more easier, right? I do remember when I do this class and I try to look for some answers from the textbook, I have to search the whole cabinet of the statistics to figure out the answer. Say, especially when later you learn about what's degree of freedom, what's the error, the definition. Some textbook doesn't give a very clear-cut things, but now with internet, then things become way much easier. So I'm pretty sure you don't have too much problem because this is just introductory class. So, but still, if you have any questions, please feel free to ask during the class, during the break, or email me or TA so that to make the question to be solved as soon as possible rather than drag it to the very end before the final exam comes. So as I said, this class is required and everyone have to take it. So the content will be same for every instructor, no matter which one you are taking. The only difference will be the focus or the way we approach these questions depends on our expertise and our experience and our preference and your preference as well. So what we covered will be descriptive statistics, probability, right? The inference, linear regression, and over. In the case for many of you who graduated from Hong Kong, who took the Math 1 M1, actually the 75% of the material has been covered there. Okay, in case you don't, you just take basic math, at least half the material has been there, right? Say, for example, if you've taken basic math already, the first 3 already been covered, and the M1 will cover up to hypothesis testing. So what is new is regression and ANOVA, and they would be just basic extension of what we have learned. So in terms of math, shouldn't be very demanding, but we would focus on some applications in terms of software programming. In particular, we focus Excel in the class. If time permits, we'll try to cover R and Python. But the time is very tight, as I told you, right? Because we are basically condensing 2 courses into single one. We try the best. But in case we have extra time, we cover R and Python. Don't worry, we will not put that in your exam. So the Python and R, if we have time, we cover. Hopefully, have time. Then would be an extension whether you like it's good for you to learn, but we'll focus on Excel. And probably you might have noticed, if you are tech savvy, then you know that 2 weeks ago, actually Microsoft announced that they put Python in Excel. So it will be released maybe within a year. So and Python and R would be something that you should learn, or at least you would know. And so luckily, although we don't have time, I'm able to secure a online portal called datacamp.com, which is a site where you can learn software hands-on. It's an interactive approach. And we are lucky that we are under the educator program after I apply for them. So the monthly fee, if you have to pay by yourself, will be like $38 per month. But we're lucky we got 6 months free access to that. So it's 3 months even after the class is over. So I do recommend that if you have free time, nothing to do, right? And you should try to look at it and take a look. I think all the email has been sent out. Might be in your spam folder, but I've already sent out. So you're highly recommended to learn from there. I mean, for me, I also learned from there for some of the things I don't know. But you are highly recommended to take a look, because usually you will cost a lot of money, but we're lucky that they sponsor us as a educator scheme. So this learning outcome is same for every course. Basically, is trying to teach you the basic of data analysis and learn the basic tools. And if you want to learn more, you will go to the subsequent course, right? I think it's 2021, which you learn more. But many of you, this will be the very last course of the statistics. So I hope at least you know what are they, right? And then that would be very helpful. So as I briefly mentioned, right, the course syllabus is standard. Probably I don't want to spend too much time on it, but I just spend 1 minute to go over what we are doing. So the first topic we'll cover is descriptive statistics. Is basically said if I have data, okay, I want to learn something from it, with basic understanding of the data. This is what we're doing. Okay, you learn that the very well-known thing you might have noticed is mean, variance, standard deviation, this kind of stuff, correlation coefficient, skewness, kurtosis, these basic stuff we will learn for the first 2 weeks. And then we will go for probability, which give you the foundations on subsequent stuff. The reason being we need to learn probability in data. The main reason is because we are never able to observe everything we want to study. For example, in business application, we want to know how much our potential client or customer want to pay for our product, right? Unless, say, suppose, consider Hong Kong. Suppose you ask 7 million people in Hong Kong, you never know the answer. So how to operationalize this is you have to ask some part of the people in Hong Kong, right? And then you try to learn something from this small sample, what we call, right, from the whole population. And you are looking at the small picture, try to infer from the big picture. How can this be done correctly? Rely on probability, okay? And that's the reason we learn probability. And we learn further the discrete and continuous version of that. That is something probably you know, the continuous one. One of the famous thing you learn is called the bell curve, right? And many of you take the exams, right? You got A, B, C, and those kind of things are coming from a bell curve. Right? Not necessarily bell, but the idea you know, right? And the subsequent chapter telling you, as I said, the sampling, right? You try to learn the idea that you want to learn something from the big picture, but you try to look at it from the small one. And how does it work, right? And then you try to do some estimation. And what I said is you try to estimate, say, people willing to pay for your product based on the sample you got. You've got to estimate. And then next we'll be asking hypothesis testing. We'll be trying to, we have some idea what's going on in the world. We try to use data to see the data support what we know, right? Say, suppose you want to see if, say, people actually spend more with the consumption voucher, or now our chief executive is very busy doing the night market, right? So you want to see if the shopping center extend their operating hour, is it going to improve the profit or not, right? So that's a question. And we need hypothesis testing to answer those questions, right? And what remains is linear regression and ANOVA. They're very similar concepts. It's in broad sense, is studying cause and effect. We call X and Y. We want to see if change in X is going to associate with change in Y, right? Something you care will be once you graduate from your bachelor degree is, should you do a master degree, or when should you do master degree, right? That's a question, and that can be answered if your data from regression are ANOVA, right? If you want to see whether bachelor make more than master, sorry, or master make than bachelor, depends, right? I don't know. Then the thing is ANOVA. ANOVA is comparing different groups, a different group making different income, say, right? Regression will be something talking about continuous, okay? Talking about if you take more courses, take more year of education, is it going to make a difference? Okay, and ANOVA is a special case of regression, as you will see when we go to the end of the course. Is there any question that about regarding the coverage of our course? If no, then I think we are going to talk about our assessment scheme. Some of you may have take a look at what I have done last year. You'll be saying we have an open book, open notes exam at the end of our semester. I think will be Friday afternoon on that day. I think that would be the case, or I don't know, is at night or during the afternoon will be best. I will ask once the ad job period is over. I will send I'll probably send an email to all of you and ask you what the preference. I think it will not take too long. I think it will be just 1.5 hours to 2 hours. I haven't decided, maybe 1 hour even, because from past experience, we didn't need a very long exam to make it work, right? Because the goal is to the grade descriptor is to where is it? Oh, is to see whether you achieve the learning outcome, right? So that would be the thing. So the next one is participation. So of course, basic attendance will be required, right? I guess I will try to see what would be the best approach to do attendance. Probably I would just try to be same as other section. Probably they use clickers. I think in the past years I didn't strictly enforce it because the COVID and things, but I think now there's no excuse not to impose it. I think that because a big class, not sure how to do participation. But I will try to see what can be done on that. I'll try to consult other lecturers for the same section how they do it. But they're only 10%, so it's very rare that you affect any outcome from my experience. So basically the test will tell a lot. Okay. Probably because it's COVID previous year, so people are not very mentally prepared. But the homework and this year I changed a little bit. So in order to make sure that you don't discourage by tiny mistake, so if you complete your homework seriously, okay, by seriously means you actually did something, okay, you will get 80% of the grade, okay, and then the remaining will be on accuracy, okay. So so as long as you did it, you show the step, then you get that, right? So probably because we'll give the assignment, we'll give you answer sheet for the answer in the first page, and then you give the working on the subsequent page. So you just give the thing for the first page, probably we don't get you the 80%, right? If you show some your step, then you will get the 80%, and the 20% depend accuracy. Okay, it's a rough grading. Okay, so the last one will be the projects. I think that although it's only 30%, I do think that is the most useful component because you actually have to work out a work that actually will do analysis using data. So I don't call it group or individual for reasons. One reason is being that some people enjoy to be lone wolf and they don't want to handle the communication issue, want to be themselves. I allow that. Some people like to be party animal. That's fine. Want to have fun and then work. That's complementarity. I mean, I do agree. So I do allow that. I think in my mind, a group shouldn't be more than 6. If you're more than 6, let me know. I mean, there's some reason why you want 6. The reason that I discourage very large group is first, I can't have the whole class as a one group, then I can't grade. Second would be your workload assessment is proportional to the group size. So I'm expecting, probably I'll give you more detail later. I'm expecting if a 1-person group will submit me a 2-page of the report. Okay, if 2-person 4-page, so on and so forth is an upper limit. So you can go below that. I give you more instruction later. But the idea is you don't benefit from having a larger group because you have to expect to do more, right? If a group of 2 people give me the same thing as group of 4, then I would, of course, discount a little bit, right, for the people of 4. And that's it. You don't have to tell me. Just give me the report at the end. So that would be the thing. I will tell you more when the airdrop period is over. So that would be the idea. So of course, later I will put the example have been done past few years to let you know what is considered to be a B+ or above projects. So I put some A-, A and B+, but I don't tell you which, right? But you can see what kind of work would be good. Maybe I just put A and A-, maybe. I mean, I'll tell you later because I haven't decided what would be the appropriate thing. But you will be working on some data, try to do a survey or try to collect some data somewhere and do some analysis. Okay. And the idea of doing project is to make a page limit of 2. First is try to make sure that you do in a business manner, which means that you should try to make your report very concise. Okay. Not to write a very long thing. Now with AI, you can write a lot of garbage easily with 1 second, right? You just give them a paragraph, say extend and make it very long, then you can make it as long as you want. So the problem now is not writing a long paragraph, rather you make a concise thing that convinces me. Okay, so and because of business, right, practice, so you should be making your report as most appealing visually as possible, right? If you lost attention for 3 minutes, then you're gone. Okay. So I would just apply the standard. Imagine I am a potential customer or your potential boss, right? Reading your report, and then how would I feel about that? Okay. So the textbook, this is same for all sections, so I'm not deviating that. Probably you ask, is it good textbook or not? I don't know. It's reasonable book, and any book would apply anyway because it's introductory class. So in case of any doubt, follow my notes, that would be fine. Okay. So there are more business version of the book, and there's some more advanced thing. In case you want to go further, maybe you want to do it. But I guess many of you are very busy already, so I don't expect you to take a look of anything. But in case you would be, you don't know what to look, then these are the books that you may want to look over. So, and standard, if you have any feedback, you are welcome to send me an email, or you can do it at the end of term. In case you have think I'm covering too fast or too slow, let me know. You can just tell me in the class, or you can email me, because right, we are trying to make sure that maximize your learning outcome, right? Because we don't have common exam, so we just adjust our syllabus or teaching according to what our class to be need, right? Otherwise, we don't need that small section, right? We just have big section, everyone sit there, right? So B school, we have a luxury of, I think, a small class, right? Compared to other faculty, right? Other faculty would have one person teaching 1,000 students, right? Or 300 students, right? We don't. We have a small class. The reason we do that is because we can cater things carefully to each small sections. So let me know if you have any question or query or whatever. So I think we are section G, all right? So one thing I have to set is because we have exam on the last week, so we have to cancel one class, and because we can't have more than you should. So happened that I have to have a research seminar this week on Thursday and Friday at other school in Hong Kong. So I'm unable to teach. So maybe I will skip. That would be, I will skip this Friday class. So I'll send an email later, but I will skip this Friday class. So after this class, I will see you on next Wednesday. Okay. So that would be, there's no class on this Friday. Okay. But there's no need to make up, because we will use the time for that for the exam. Okay. So okay. So let me repeat, there's no class on the Friday. So you can enjoy your Friday, whatever. Okay. So last is honesty thing. I guess this is the middle of the week. Probably you have heard that from many other classes. So my announcement will be no different from the others. The only thing I want to mention is for your project, right? Highly likely that you use AI, which I cannot control, right? So make sure that you do proper citation, because AI gives wrong citation and make up statistics. So if you do a shortcut, make sure that look at the primary source whether they actually the right thing. Okay, if you actually have to use AI to help you, ask the AI to give the source and check it by yourself, because at least as far as I know right now, the AI is not 100% reliable. Okay, you are responsible for your work, and your group member also responsible for your work as well. So make sure that you don't make a mistake, right? Because if you say something fake, then it is problematic, right? Because as far as I know, CHK do not allow AI. I mean, I think Hong Kong U and USD they do allow, but as far as I know, they don't have a policy that allow. So if you figure out that you make up from AI that I don't know what to do, okay, I'm not sure what will happen. So make sure that it's not use the benefit of doubt not using AI. Okay. That's pretty much of the course introduction. Let me know if you have any question before we proceed. Any question? Okay. If not, then we go right away. Okay. So what we cover today will be descriptive statistics. Okay. Just to remind you that the way we conduct the class will be standard way. So we have 45-minute class and then 15 minutes break and then 45-minute class. Okay. If I ever go over more than 45 in the first section, I will make sure that you got 15 minutes break. Okay. And do remind me to stop the class because many of you need to go to grab the lunch or grab the bus. So I try to make sure that everything is within the time limit. So what we're doing today, let me turn this on. Okay. So I don't know the time, so let me know if the time is up. Okay. The idea is to go over all the basic concepts you might have already learned in your high school or primary school, but that is necessary because pretty sure after many years you will forget. Okay. So let's start with the idea of statistics. Okay. As I told you 10 years ago when I studied this, actually divided in two courses. The first course will be called Descriptive Statistics. The second one will be Inference Statistics. So what's the first one? First one is we talk about things actually is we're given a data. Okay. We are trying to get things from the data. Okay. And that include making a graph, making a table, or we do summary statistics like mean, variance, this kind of thing. So that will be actually the goal today. Okay. And the next part we'll call inferential statistics. Okay. Which I have hinted that will be something that based on data, we do some estimation, we do some prediction. It generates new thing out of the data. Okay. The first part is that no new thing. We just discover things from the data. Okay. It's like archaeology, right? It's like taking out the mud from the ground and taking out something. Okay. Inference statistics is different. It's trying to like inventor. Okay. You invent something new. Okay. We're trying to see using, as I said, using a small picture to figure out what's going on in the big picture. Okay. We're trying to make some educated guess. Okay. From there, trying to predict the future, trying to guess what happened, looking to see the small thing, try to guess what's going on in the big thing. Okay. As I said, in order to connect these two parts, we need to learn probability. So that will be considered of the second middle part of our course. I hope that will be clear what we are going to do in the next 13 weeks. Okay. After knowing statistics, we have to know the main thing we want to know, right? The data, right? Because without data, there's nothing, right? This class. So everything in this class is based on data. Okay. Either we summarize the data, or we're going to use the data to make our guess. So it is very important to know what kind of data you are having. Okay. Because as we know, garbage in, garbage out. If the data is bad, then it's bad. Right? And you have to know what kind of data you have, because there are different tools to handle different data. Right? Just like you go to a restaurant, you go to a Chinese restaurant, what you're going to do is use chopsticks. Right? And you go to a Western restaurant, you will use forks and spoon or knife. Right? So it has to depends on the thing. Right? If you use chopsticks to eat steak, that will be very difficult, right? It's doable, but it's very difficult, right? Noodle, you use fork, might be fine, but it'll be a mess, right? So the same idea. The data is where you have to be very careful. What kind of data you have, you should use the right tool. Okay. The first one is what we call the classification. It's called categorical data and numerical data. So most of the time, we will be working on the tools on the numerical data, the number. Okay. Because we talk about the mean, average, those kind of thing, is number is easy to handle. Okay. It's not because it's because the tools to handle numerical data is much easier. Okay. If you actually want to do categorical data, actually the tools will be much more difficult. Okay. Indeed, if you want to do it seriously, you have to go to very advanced class to know how to handle those. Okay. But nevertheless, we often have that data, right? If you do a survey, you got a nominal data like gender, races, right? Or right, these are 0 or 1 data, or 1, 2, 3, 4, 5. You put number there, but it's not a number. It's category. Number has no meaning except you put that number, right? Say, for example, the nominal data, right? Whether you study in Chinese U, whether you are a B school student, right? Whether this class is called 2110, their number, but actually the number has no meaning, right? Just a category, okay? Putting a category there actually means nothing. There's no ordinal idea. Order doesn't mean anything, okay? And the other one is ordinal data. Okay, you give number there, the number actually has some meaning. It just that only mean usually larger the better. Okay, for example, you have a Likert scale. You will do cost evaluation at the end of the course, or you are doing the online survey, right? Is you give 1 to 5, whether you like it or not. It just means the larger the better. Why? Because if I add 1 to everything, there's no difference. Right? Or multiply by 2, there's no difference. Right? The reason is because, right, you put, say, agree is number 4, strongly agree is 5, right? Natural is 3, that's usually you do, right? The difference between 3 and 4 is not the same difference between 4 and 5. Just like you go to book a hotel, right? 3-star hotel, 4-star hotel, 5-star hotel, right? The difference between 3-star and 4-star is not different between 4 and 5, not difference between 4 and 5 and 6, right? The difference is not meaningful. Why I have to emphasize this? It's because in that case, you calculate mean, which we'll talk about formally later, has no meaning, right? In that case, median would be a more appropriate thing, which don't involve adding, dividing, right? So you have to be very careful what kind of data you do and what kind of tools you're going to approach, okay? So because of this, actually doing this is way much more difficult, okay? and it will be beyond our scope, okay, to talk about those, okay? So most of two will only apply for numerical data, okay? And we will do, say, count data, okay? Say, how many cups of coffee you drink every day, right? How many number of children in the family, so on and so forth, right? Or continuous variable, right? Temperature, stock price, these are very important. And they're important distinction for content discrete, okay? And again, because of our limitation of the coverage, most likely you'll all likely handle continuous variable, okay? And if your data is actually count, actually would require some more advanced technique to do it. But just now you know, I mean, probably you forget, but I want to emphasize that most of two we learn is just focus on continuous data. And if you're actually doing discrete, ordinal, nominal, actually require some further tools, which we don't have time to cover. Okay, it's not, we don't have time to talk about, but everyone in the same course code don't have time to cover anyway. But that is. So here we talk about descriptive statistics. One important part is called the visual representation. Okay, and I mentioned that. Oh, I didn't have that slide. Okay, I don't know why that slide is gone. So, the way that we do is here, right? We have visual and numerical. Okay, and the visual one, this we only slide we mentioned visual representation, but nevertheless, in fact, this is the most important part in your project or when you go to work. It is not how deep analysis you convince other in the first time. It's the graph or table you convince other first. Of course, your results should be supported by rigorous analysis, but how can you get attention from others is by tables or chart. Without the appropriate chart or table, you lost your attendance, right? So you lost your audience, you lost the attention. So although I don't have time to go over, but you do see here the chart, the type of chart you're going to use actually depends on data, right? So that's why the data type is very important. This shows you have to know your data very well. We don't have time to go over this in our class, but when you do the group project with the kind of data, you have to be very careful, okay? What kind of data to present in your chart, right? Unfortunately, our class don't have time for presentation, right? But if you actually present, then you have to be very careful how to do those, okay? And I think bar chart and pie chart you see every day. I don't think it's a problem. Histogram and polygon, of course, you know every day as well. So I don't want to do it. I think you learn it in a primary school or secondary school anyway. Okay, so if you forget those, okay, take out your phone during the break and check it out, or ask me. And something that probably you also see is the scatter plot and line chart. If you look at financial market, line chart actually every day, right? Scatter plot is very important to show how things are related, right? If you want to see, as I said at the beginning, whether you study master program is going to help you earn more, that will be the thing, right? Or you want to you are the marketing manager, you want to convince the CEO, let's spend more on advertising, right? Then how can you convince your boss, at least to say, the more market expense we do, the sales goes up more, right? How do you do it? Scatter plot, right? So that would be the thing, that the basic thing you need to use. Okay, so so in order to represent data set of a variable, okay, we usually have three typical representations: central tendency, dispersion, and shape. What is central tendency? Right, basically is if I give you data, a particular variable, say income or sales, whatever variable you care, I want you to give a single number to represent the data that you will use is either mean, median, or mode, which will go a little bit detail. And at the end, we'll talk about Excel, right? How to operationalize them. Okay. And second, we'll talk about dispersion. And what are these? Okay. Because you use a single number to represent the data, a very natural question is how accurate is that number? That would depend on how spread are the data, right? If all the numbers are concentrated near the center, right, the mean is very useful. Otherwise, it's not, right? So you want to know how data is spread out. That is what we call the range, variance, standard deviation, okay, this kind of thing. And after that, we want to learn shape, okay, which you probably don't learn in the high school, okay, which kurtosis or skewness, okay. Skewness is asking whether, look at the shape of data. If you draw a histogram, probably you will see is whether the histogram is going to be skewed to the left or skewed to the right. Is it going to be symmetric or not? Okay, that's called skewness measure. The next one is called kurtosis. Okay, kurtosis is looking at the outlier. Okay, you're looking at the data. Okay, and probably you can think about an extreme case of variance. Variance is asking how the data spread. Okay, but kurtosis is looking at how the extreme points are, how extreme they are. Okay, and probably you would wonder why we care about kurtosis. One reason is being that if the tail is very fat, okay, a lot of extreme value, the standard way we do the bell curve thing, everything fails. Of course, it fails, it means we need more advanced tools, okay? But we can't cover those, but at least we give you a check whether you need to use advanced tools, right? If the data shows there are a lot of extreme values, then you have to be very careful, okay? What to do about data, okay? Of course, the simplest answer, what you can do as a shortcut for the group project in case the data is very extreme data. Suppose that, for example, you collect a hotel price data, you get a lot of prices, and turn out that there are a lot of prices are very high. Right? Suppose you go to Macau, right? And I noticed someone told me that the hotel London, whatever, right? The price is like $7,000 per night. So you try to calculate the average price in London, or in Macau, that would be crazy. So what we're going to do, if you take this out of your data, right, out the outlier, and then the kurtosis will be within control. So if you outlier, you just drop them from the data. We'll talk about this more after the break. So it's time now. So let's have 15 minutes break. We will resume at 11:30. I go around to see the next question.
Soccer 夢嗰啲北美嗰啲劇啊，唔係啊，佢都會
It's not.
My God，可唔可以走？我對自己4個喺層。我支波而犀利係咯，不需要黐線嘅，真係可以。
I go out and drink coffee. If any question, just find me there.
好似啲咩外國 professor 都係食煙，呢啲人跟住。
Medical read， 見到佢有 depression。攞分病，其實都有9題。你禮拜一咁樣跑，
係咯，勁得啊！快到死。唔係佢好似有呢個啊！我睇好你哋啊 ！B 級睇好你哋。我哋最尾唔係sorry 垃圾啦，西卡。我唔係前途嘅原來 ，sorry。好。我識睇有人咯，係啊，我睇咧你 present。你佢會問你問題。走晒啲 training， 佢係淨係最後先 show up， 你都可以走。做個4嘅。一個CCT 嗰個 Zoom。我個 Zoom 要係。bonus 嗰啲你可以走，你因為 Brady 走晒，不如都想同 Mingo 你嘛嚇？唔係年年都 bonus，D 級係一佢明。你可以即係咧即係 Dennis 我嚟講冇 B 級咧，係因為 Dennis 新嚟唔知咩叫 B 級。新嚟嘅 staff。我哋小約喺度，我哋 exchange 個小約。我講 staff 啊 ，S。佢想食 Esther。我想食。中意啲CM。都係。捉人哋 A 級。縮水啲 A。我哋個下 batch 嗰日好似認咗 Esther。A 級有個 brief， 跟住前面嗰個係 Esther。冇人上市，冇人係咯，唔使話呢個啦，上邊攞1萬啦，1萬咯。
係上年多㗎嘛，有少
因為冇 choice 嘛，上年係 typical。
雖然呢次我都唔夠啲。
有幾多 IBC 嘅？
我玩呢個一定。
好多係啊係啊好多。
咁我要買係好多。
咁多嚟咗。
我一眼點問係先知
係啊，唔會着。我想講唔係。
你夠唔夠冬天着啊？
食過你食咩事啊？
要翻到最嗰件衫，即刻有資訊。CCT 嗰件係嘛？
你點樣形成？我都話太大件咯，件咪。我唔明白佢可能你係將屋企嘅嘢最快。唔係 Sally 係 group 聲。
下個星期。
你會唔會啱翻手指啊？冇咁裝你可能好想問。但我又冇話好想之前上一課，因為一定即係天上一課。
我想咩？其實。
Why not? Why not? 你之後講咧，
你同 Sally 分析下先。
你同 Sally 邊個下
I will try。會 try。
幾時開始？唔好講。做咩？我哋笑死係咪？其實唔記得你其實咩？
係咪先？我受唔到啊！你合拍得啦。
我睇下睇。
都我所講嘅，我未寫乜多。
係啊，佢有電話嘅。
我4蚊。
你10屆做咩教學生仔嘅興咁屆？
你覆咗未啊？咁你唔好嘈啊！我之前教錯咗，
我上
交咗先。
咗啊！
係，跟住咧。
你冇講，
我咪教
到你啦。
咁教。
我識 send，我識 send 咩叫串串？我知唔想。
因為佢咁 nice 又唔可以串。
因為我真係串咧就
做乜嘢？
呢個串串地。我唔記得，我唔記得咗人哋會見到咯。
咩？
唔緊要。
一定係叫我。
真係嘅。哦。
我哋係 year 2咯。你其實如果你係 handle 自己俾自己派你個自
碌卡街啊！
哦，
佢點會？
哦
rock
卡。
係啊，
要寫伊朗文咯。
寫伊朗文，真係會死。
OK，叫做。
Concern。
我唔係 WhatsApp
3個食晒。
但係 Navara 嗰個好似係3624，佢仲要係冇得用電腦添，
係啦，
冇 internet。
但係即係個 expectations for everyone 會低。
喂，
因為你唔講。
哦係，嗰陣佢哋唔係喺度。
即係個
得兩部電腦咯，仲要好似
係啊，
嗰陣佢哋 case 唔喺度整，即係個大
佢揾佢哋間房，
係啊，
收得
好癲。打翻嗰隊
啊，唔係
係得晒，
3個鐘你點嗌 P
係得晒。
好棘啊 ！P 晒，跟住仲要收唔到咧，嗰個人喺出面上到去，跟住聽唔到電話，佢冇出車，因為佢冇出車，即係佢有個 confirmation， 你唔聽佢就冇出車。
上年去打翻咁佢去打晒。上年去打翻。
應該我都休息咗幾耐咯，瞓咗14個鐘咁咯。係啊，我見啊，好精神嘅。你做咩？
你上所堂瞓覺。
我琴日做。
唔係啊，覺得睇咩老師
都係香港教程度啫。
我都成日食水晶膠，我每次買完一包一日清晒，好嘥我錢，sorry 啊。
係有晒錢。
你都係瞓嘅，係咯。
我係有上 batch。
今日成食咖啡定佢都係
係有翻嗰
嗰啲係啊係啊。
但係
好似係咯，掛住飯都唔係，我要等係等佢飲晒啲先。
我飲幾多番茄嘅？我話你要用咩？香港教係做
有啲嘢做下，一路都真係有分享。
online 嗰個
online
其實
係
virtual 嗰個
virtual 係 Wendy Sharon
唔知喎，希望啦。
其實我覺得你係邊個？
呢度晒得佢唔去。
我 stand 係 DSME，我中意 DSME。好神奇啊！有咩佢唔知？GPS database。
唔係啊，
你有咩想 search 咧就問。
now that I know
Crazy story。
嗱嘅先。
我唔會播啲 virtual。
要一早食晒，即係嗰啲嘢。佢呢度咩？上到成日 GPS，佢應該出嚟係啊。我未到成個所索咗你個。
點解會知點解我知？點解我知緊佢？
佢哋唔係啊，要知我唔使邊度。唔係啊，即係自己
佢哋唔會咁諗應該。
唔係嘅，可能有啲 influence background 㗎嘛。
仲有邊個得 S
都係要我哋都係啦。
睇你人。
唔係啊，即係
我 send 俾你。你有冇理 case？
Okay, I think time flies. We resume. Okay.
佢三個都行。
其實你即係上個四個。
So just to recap a bit what we have done. What we are doing the first week is talk about descriptive statistics, and I do mention that the visual representation is the most important, but I don't think we have time to go over how you draw a graph. Okay, it's something you learn from the art class, you learn from your primary school or secondary school, right? And but we will focus on the numerical representation, mean, median, mode, variance, those kind of stuff. Okay, so let's get started with central tendency. Just to recall what is central tendency. By definition, is a single number that to represent the whole data set. Okay, so the natural thing is the center of data. And how do we define center of data? There will be 3 different ways. So that means that there will be 3 different measures. Okay. The first one, everybody knows. Before we do it, we need to introduce some notation. The reason why we use notation is not because I want to go mathy. It's because all the books is written in this way. Okay. So if I don't introduce notation, it'd be a problem. Second, it's because of the fact that you will be writing program, at least working in Excel, right? It's implicit programming. So in order to do it, you need to know how the formula they are, because you need to transfer formula to the programming, right? In case you do Python or R, that will be very useful, right? So first with notation, small letter n is the number of observation we have, and each observation we have is x1, x2 up to xn. So we in our mind we are restricting ourselves to one single variable. So we have single observations like income, right? With n people income. So x1 is income of person 1, x2 is income of person 2, xn income of person n. Okay. And here I think is the most terrifying notation. It's called summation. Of course, from people from QFN will be said very simple. So, but that if you're from accounting, that will be a little bit challenging. So this summation notation, because it's a Greek letter sigma, it's S, right? It's actually S, sigma. It's adding from 1 up to n. You write this, it's just adding. It's a shorthand notation for this one. Okay. The reason we need that is because if you ever going to write the proof for the regression ANOVA, all those kind of things, we need this summation notation to save our writing, especially when we write slides, right? It's very condensed. I cannot write it out, right? So this is the notation. And the next two will be a function that you use in Excel, okay? And it will be useful to make the formula more condensed and much more easier to use. It's called the floor function and ceiling function, which you often use it. Okay. The floor function means run down, which means that you ignore anything in the decimal places. Oh, just get integer. Okay. And if formally will be this biggest integer that is smaller than the number, right? And the ceiling will be the run up, right? So 3.1 is 4, but do you know that 3.0 is still 3? Okay. 3.99 is 4. 4.01 is 5. Okay. So it's the smallest integer that's larger than number if you define formally. But anyway, you will have this in Excel, okay? And you use it in Excel anyway. Okay. So that is the formula. And we also need to introduce what we call sorted data. Okay. The data is sort in our definition will be you arrange the data from smallest to the largest. Okay. You can do other way around, but we just focus on the case where the smallest largest, the same thing. Okay. And we define what's the frequency. Frequency is the thing that we do when we are 3 years old, right? We count 1, 2, 3, 4, 5, right? So we count how many observations have the same value of x, right? It's called frequency. Okay. And we define relative frequency is the frequency divided by n, which is total number of observation. Okay. It's a fraction, right? Between 0 to 1. Okay. So give example. For data, you have 1, 2, 2, 3. F of 1 is equal to f of 3 with 1. F of 2 is 2. Okay, because 2 appear twice and 1 and 3 appear once. Okay. Now, this is the last table. Then we go to the mean. So we call the contingent table, which is counting and tallying, right? Just basically do the frequency table F. Okay. And this is a table that you will try to get a look and what the data looks like. Okay. And the other one is called the contingency table. You can see this say suppose the entry 15, the first entry, is out of 80 students, 15 are male and pass the exam. Okay, and do note that this table actually each number have two nominal variable. Okay, they have tell you whether it's a male or female by gender, and also pass or fail. And later you will see we will use this kind of number to do ANOVA, which will be second to the last topic of our course. Okay, so we will not see this until very late at the semester, but this is a beginning, so that you know what's going on. Okay. Now we can go back to talk about the 3 ways to summarize the data by means of central tendency. The first one, everyone knows it, right? Average or mean is adding all and divided by how many of them, right? The notation, right? Summing 1 up to n. So there's nothing, everyone knows it from your primary school. So what I want you to look at is, do note that we have addition and division. So this thing have to be meaningful if you can add things. Okay, you can divide things. Otherwise, average has no meaning. Okay, and make sure that they're the same unit. Otherwise, you don't add, right? So that's why sometimes when you do addition or average, you have to normalize things. But we'll talk about that later, because the C-score on when you can add things, right? And well, actually, that's what you do. I mean, many of you from Hong Kong, right? You take the what do you call DSE, right? The DSE, how you add the marks is every subject, right? They give you the grade ABC, right? You should say, I don't know. I did DSE. I do the old version anyway. But anyway, they each of the grades from each subject will convert to a number, add up, right? You don't add up the raw score, but you add up the normalized score. So why? Because you add up the raw score from different subject has no meaning, because some subject may be more difficult, some is more easy. So that means that you have to convert things into the right scale before you add. Okay, so just to remind you again, when you do adding, add has to be meaningful. Otherwise, you're adding something, you just do the wrong thing. Okay, and the median and the mode don't have this, don't have adding. Later you'll see, right? So you only apply adding thing when you can add. So that means that you only reasonable when you talk about the numerical data, right? Discrete or continuous, you can add. Okay, you try to apply this to ordinal data, that is not very good, right? So that means that when you often see, there's often abuse in the real world, is you look at the mean, look at the restaurant tonight, want to eat with your boyfriend or girlfriend, you check the restaurant and they give you a star rating. They actually usually they give you the average, but the average usually mean not a lot, right? But I mean, it's still, I mean, actually, if you look at the theory, will tell you that when you have a very large sample, the average still means something, but it's not that useful compared to other things. If I were to look at the restaurant, probably I look at the median rating rather than the mean, right? Because to me, if the restaurant is 4.3 or 4.4, 4.5, does it mean a lot? I don't know, right? Because it's not comparable. I mean, 4 to you, maybe 5 to me, and 5 to me, maybe 4 to you. So it's not adding is kind of weird. Okay, of course you can say, okay, there's something, it means something, but it is not what it's supposed to be. Okay, so in the slide you see I have the black and gray square. It means it's technical, so you can ignore if you prepare your test. Okay, but I would want to give you some background. Okay, that would be good to know. And the thing in the assignment or most of the thing, and then basically you only need to know the purple thing you should know, and the green thing is the example, which you should know how to work on those, right? Because this is explaining how the definition being used. Okay, so if you want to revise, the purple thing and the green thing is the must. Okay, The black one, if you want to know, you know. If you don't want to know, it's fine. Okay. But I think it's good to know what's going on because you're a business school student. The formula probably mean little because at the end of the day, you would plug in the computer and that's it, right? Unless you're actually writing the code or the thing. But of course, for QFN student, you have to know, okay? And but if you're accounting, then probably you don't care that much, okay? But you have to know what is the meaning so that the meaning is given in the black one, okay? What is the meaning of the mean? Okay, mean is actually the center by distance, okay? And the idea is you just rewrite the formula. It just means that if you take the sum of each observation minus the mean, that is equal to 0. Graphically, what does that mean? Look at this picture with the simplest. Where is the location of the mean? It's looking at all the distance to the left is the red, and this on the right is blue. You adjust the mean such that the distance of the red is same as blue. Okay, let me repeat the statement. The mean is x bar, right? The distance to the left is this red one. Distance to the left is the red one. The blue is this guy. The mean will you keep moving this one so that the distance to the left of the mean and the distance to the right of the mean will be the same. So in the center of the data. Okay. Again, you can see the definition is coming from distance. So that means that this will be meaningful if distance is meaningful. That's why I said ordinal data, this is not so meaningful. Right? But you still will use it. I mean, but that is let you know the idea of mean. The second one, well, pretty trivial. But just saying that if you are to replace every value of the data by the mean will be the same. Okay, that is exactly what it means. But I think the first one is something that is to convince other people what is the meaning of the mean, right? Why the adding thing divided by this is something we want is because exactly center of data by distance. Okay, that's the idea. Is that clear? What about the mean? I mean, I quickly go over the example because I think everyone knows it, right? But I want to highlight that. Look at the first one is 1 up to 5, adding up to 5 is 3. The second one is 1, 2, 3, 4, 50, and the other 5 is 12. And you do notice that if the last number become from 5 to 50, it is substantially increase the mean. So there are two things coming out of this example. First, the outlier change a lot. So that means that if you have error on the end, then your mean will be screwed. Right? So that would be very, very, very problematic. Right? The second one is if you do sampling, later you will see, right? Then the sample size would be very important. We will cover the mean, right? Because the idea is if you have small sample, if you have a sample that is very outlier, then things will very biased. Right? Suppose you go to Macau, as I said, and that's what I do. I mean, I go to Macau last time. It's my first time go to Macau. I mean, very surprising. I mean, I went there. I noticed that the hotel price is very expensive because I look at that one is like 7,000 per month, per night. So, but I mean, it's outlier, right? But you happen to have an outlier in your sample, then it skew a lot. So have to be careful. And the second implication is when you calculate the mean, might be you should take out the outlier. Okay. And that will be the extension part we mentioned here. Okay. There are two ways to handle outlier, right? Either you just report this, okay? You just report what you have. Of course, that can be problematic, right? Because you know this is likely to be an error. Okay. So how can you handle that? Okay. First, either you would take the sample out, just cut it, right? That's what I do, right? When I go to see the hotel in Macau, that particular hotel is so expensive, I just take out my sample and just do average for the rest. Okay, that's where standard. And that's what we do is if I take out the last one, that should be fine. 2.5. That's one way called trimming. Okay. And the second one is less drastic. It's called renderizing. It just say I just take the nearby number and replace it. Instead of 50, I put 4. Okay. That's called the winsorizing. And which one is better? It depends, right? For trimming, if you believe your data coming from outlier or mistake your collection, then trimming is better, right? And winsorizing may be better if you think there's a measurement error at the end, right? Suppose you got the income data, right? And you ask Lee Ka-shing how much he made, right? He may give you a number, but maybe he even actually don't know the number because he's so big business. Your number may not be even correct. And it's so big that actually doesn't mean worth to look at that, right? So basically, winsorizing is better. Method you should use, your results should be robust to that. Okay, so it means that you should be thinking about how different way to handle the outlier. You still get a similar result. It's not sensitive to what you're doing. That your result robust. That's you should also do. And what actually people do in practice is do different way to handle data, and the results do the same. Then you are safe. Okay. Is that okay? I mean, of course, this is more advanced. So if you get it, don't get it, it's okay. But of course, you're still welcome to ask me. But if you don't get it, you're happy to keep it with you. Probably when you learn along the line in this class, there's something that we don't tell you the detail. We just say, okay, trust me or trust the textbook, and that means that you have to live with the problem with you for a very long time until you actually study later. Then you know a lot of things we can't explain. Okay, or if you explain, you will need a lot of math. So you have to have a trust or belief. Okay, it happens, right? Just like you don't have your iPhone, your iPad, or computer, you don't know why it works, right? It works. That's it, right? So you don't care too much. So sometimes you have to keep your curiosity there. Okay, you have to live with that. Okay. So there are some other average that you use. I just briefly mentioned. The first one is weighted average, okay? And this is the one that you often use. Actually, there's the first example. You can see the first bullet point, the GPA, actually the one that we often do, right? And I often mention to the student in this class is you have to study this class more. Why? Because our class is 4 credit compared to other class, 3 credit. So spend more time on this class. Right, because the return or studying more class, studying 1 more hour in this class is higher than other, right? Suppose you spend 1 more hour, you get an A here, right? Then you maybe spend the same time in other class. Now you only have 1 hour, so what are you going to do? This class, right? No, I'm not saying that you give up other class, okay? I'm not saying that, but in case you only have 1 hour now, I mean, what to do and right, this class. So the other one that often you see the weighted average is called the Hansen index, right? Hansen index is the one that depends on the size of the company, right? When you have Tencent, right? Tencent, right? Tencent, they go up a lot, or in the old days, HSBC, they go up a little bit. They move the market a lot, okay? Because why? Because it's weighted index, right? So it depends a lot on them. So QFN student can teach me on that, but that would be something easy. Okay. So the next one is moving average, also with the finance, right? The moving average, when you look at the traders, a lot of chartists, probably some of them are here, they're trading. And what they do, right? Look at the average line, right? The average line will be a lot of time, it will depend with the average is the price history that is more recent is more important than the distinct price, right? So it's a weighted average. Okay. And the difference between the simple average and weighted average is the simple average, every observation carry equal weight. But weighted average is just give different weighting to different one. Okay, so that's the thing. Is that okay? I don't think that I need further discussion on this one. But give example, right? Suppose 1, 2, 3, 4, 5. The weighting is 6, 3, 2, 3, 2, and simple average gives you 3. And the weighted average gives you a smaller number. The reason is being that observation value of 1 get a weighting of 6, right? So that's why it's smaller. So just example. And technically means you can also consider simple mean is actually weighted mean. It's mean weighted by frequency. Okay, the more you see, the more often you see, you give more weighting. So I'm not going to talk too much about this one. And lastly, beside the normal mean, we have geometric mean and harmonic mean. Okay, in particular, for QFN student, they would know very well about the geometric mean, right? The reason is the following. I should have blacked out this one. It's technical. I have to black this one out. Which is technical, even the green is also you can also safely omit. The idea is when calculate return, when you have reinvestment, the average return should be calculated as geometric rather than arithmetic. The reason, look at the following. Consider two opportunity of investment. The first one will give you 10% in the year one, and the second year give 90%. The other option will give you 50% for both years. Which one do you want to go? If you use arithmetic average, you will see the same because 50% each year, all right? But you would notice that if you allow you to invest, what option you choose? I mean, QFN student obviously would choose 2, right? Yeah, because you calculate, right? You calculate the return. If you can reinvest your money, option 2 is much higher, right? So that would be the idea behind. So that means simple average is not the greatest thing, right? Because it's not adding thing, because you reinvest. So that's why adding thing, already you make some assumption there. You have to know what is appropriate. Okay? Do you see the argument? It's because you adding thing up and divide. It's not the right thing actually you're considering. Right? It's okay for the mean, I guess that should be no problem because you learn it in your primary school anyway. Just give you idea what's going on again. Give you some caveat, what can be applied, what can't, and there are a lot of variation on this. Okay. Median, and median by definition is very simple. You just order the data, just the middle guy. Okay. Idea is very simple, but what is middle guy is unclear. Okay, if we clear, suppose we have 3 observations. Exactly the second one, the middle one, the middle is clear, right? Suppose we have a data 1, 2, 3. The median will be just 2, right? The second observation. But what happens if we have 4 numbers, 1, 2, 3, 4? Say, for example, observation we have 1, 2, 3, 4 very naturally. So what's the middle? The middle one is 2.5, right? Then what's the middle? Is it 2 and 3 or somewhere in the middle? Okay. And how can we do? Okay. What do we do usually is doing the average of the 2. Okay. You're averaging the second observation or third observation in case of 4, n is 4, right? But do notice this is already problematic. Okay. If you are not talking about numerical data, right? Because you get average of the 2 numbers, right? Remember, this only makes sense if you can average. If not, it's problematic, right? Maybe you can use geometric mean in that case, right? So here I have to be very careful. I follow the standard, use the average, but by no means it should be average. Maybe better to report the 2 numbers if they are 2 distinct, right? If say the data you have is 1, 2, 100, and 101, I don't think you should report the median like 50 something, right? So you should be careful when you apply median here, right? Sometimes maybe you have to report 2 numbers instead of doing the average, but I mean, we just follow the standard, give you the standard mean, so you have to be careful, okay? And let's look at the formula. Okay, when we have exactly odd observation, there exists middle guy, which is m plus 1/2. Why? Just look at example. If you have 3 observations, right? The middle guy is 2. How do you get that? 3 plus 1, 4, 4 divided by 2 is 2. So that's why it's m plus 1/2. Okay. I mean, if you are not from QFN, probably you might have to trick a little bit to get m plus 1/2. I mean, for me, I from IFAA, but I twist my mind a little bit. But anyway, there's no IFAA here, so that's safe. N is even. When N is even, then as I said, you have to go a little bit difficult. The formula is N over 2. The reason is suppose to consider the case we have 4 observation, right? The middle guy is between 2 and 3. How can you do that? 2 and 3 will be 2 is N over is 4 over 2, right? And will be 2 and 3 plus 1. Okay, it's halfway of the 2. Okay. Just to remind you again, there's no reason to use half, but we just use it. Okay, it can be anything. Can be any combination, can be geometric mean, can be any harmonic mean, can be any mean that you think it makes sense. But here we follow the standard thing, average. And so you can notice that this formula is rather ugly because odd is some number, even some number. How actually you can put it in the right formula, or actually look at the Python or R, if you learn it, actually they will give you this formula. Okay, the formula will be n plus 1 the floor, n plus 1 over 2 the ceiling. Why is the case? Okay, the reason you can see when n is odd, n plus 1 over 2 is an integer, so immediately go back to the formula, right? Because the floor and ceiling has no bearing when this integer, so exactly the same formula, right? And you can easily prove, okay, by example even. So look at this will be actually n over 2, where this is an even number. Okay, so if you don't believe that, as I said, you have to believe it on your belief. Okay, trust it. Okay, that's the formula. Okay, it can't be wrong. Okay, you can test it. If you're wrong, let me know. It can't be a typo. Okay, so then be an issue. Okay. So the implication of median, as I said, is it disregards distance, the middle. But this statement had to be qualified a little bit because of when observation is even, there will be some distance, right? Because it's the middle of the 2 observation. But usually we don't care them too much, right? Because still middle, right? But you just pick any point in the middle and you pick the mean, okay? And that's it. The good thing means that look at the example here. Regardless of the first one is very simple, right? The median is just the middle. And the second 2 example would be regardless of how you change the number, the last one, right? Whether it's 4 and 40, it's still 2.5. So there are 2 things here. One is your median is not subject to the outlier. The second would be our measure would be robust even you have measurement error at the top at the bottom. Because when you look at data, very often you have issue with the outliers. When you extreme value, it's very difficult. Suppose you look at the income data. You want to look at income of Lee Ka-sing or the rich people. They don't even know how much they worth, right? Because look at the antique in their home, right? Those things, or how many wine in their basement. You don't know. You can't estimate that, right? And you try to ask very poor people how much they earn, how much money they have. Probably they don't even know. They don't record it. Maybe they keep their money under the bed, and it may be eaten by the mice or cockroach. You don't really know, right? Or you look at their wealth, with the TV, they're working or not, you don't know, right? So there's some issue. But say for wealth of the average people, probably you know easily, right? So that means that the median compared to mean, you don't require too much accurate information at the top, at the bottom. As long as the middle thing, the order, then you're done. So that is the benefit of using median. And that's why and median is more relevant. So that's why look at the income data, right, from the government. Usually we care about the average, the median income, 中位数, the median, right? They will care about this one, right? Rather than the 平均, okay? The last one is called the mole, okay? And mole is the most frequent value, okay? And you can see in this operation to find a mole, we never use any addition, right? We never use subtraction, any operation, right? So basically what we do is look at the frequency table. We look at the mole, look at the value that appear most, okay? And here the thing is one of the good or bad thing, I don't know, with benefit or the feature is you can have more than one mole, okay? Because it can appear multiple times, okay? And some textbook would be a little bit picky. I don't know whether we should do that, but if they would say if every value only appear once, then no mole. But I don't think that would be a problem for application in most of the time, because if your data such that every observation only appear once, okay, you want to use the mole, then you should group your data. Okay, you should group data, then you should appear as a model group. Okay, so you never be an issue when applied in practice, right? And so that's not an issue. So if even after grouping, every group only appear once, then you should use a more coarse group. Or if the data is so diverse, then probably mole is not very useful anyway. Okay. The reason why I do this is because when you do programming, that would make more sense. When you're programming in the R or Python or Excel, right? When you appear once, right? Look at the count. That would be easier to. I think it's much more simple. Okay. So this is the way we do. If I 1, 2, 3, 4, the mole is 1, 2, 3, 4 because everyone appear once exactly. If I 1, 2, 2, 3, 3, 4, then the mole will be 2 and 3 because they appear twice, right? And if I 1, 2, 2, 2, 2, 3, 3, 4, then it's 2 because 2 appear the most. Is that clear? So do note that as I just want to emphasize again, in finding the mole, we don't do any operation except counting, right? So it means that it would apply to any data you're using, right? Just count. So there's no, unless you say you can't count, right? Because if you count, there's no data, there's no point. So that means that it applies to any data type. So mole would be thing that's less restrictive. Okay. Is that okay? We finish mean, median, mole, which I think just a revision. Now, if there's no question, we go to the other one. Okay, is this person. This person is talking about how accurate our mean, median, mole they are. Okay, how representative they are. Okay, and we have basically 4 or 5, depends on how you view it. Type of measurement. Okay, the range, IQR, variance, SD, and CV. Let's go one by one. The first one is range review. It's very simple. Range is just the largest minus smallest. Okay, look at the largest data minus small number of data, and you see how spread they are. Okay, and basically, if you sort the data, it's just xn minus x1, right? Because our data is sorted in ascending order. Okay, so of course, the drawback is we just look at 2 numbers, the largest and smallest. It can be outlier, then your problem, right? So like this example, right? The example we have for the mean, the range for the first one is 4, the second one will be 49. So again, what you should do when you got the range, if you have to use the range, how we do it, we should trim or windsorize the data, right? Drop the outlier if you want to use the range. Okay, if you want it after winsorizing or trimming, you still get the similar idea. The range would be a decent measure. Okay, and also it's very simple, right? Is that okay? Now we have introduced the idea of quartiles. Okay, the quartiles by English, quart means 1/4 or 4, right? Quarter, quadrilateral, quadrihedral. Okay, and tiles means the thing you see in the bathroom, right? The tiles, the square, right? And quartile means you divide the data into 4 equal parts, right? And let me draw it. So this is the, can I draw a face? Yeah. So the data, I put the data there, right? And this whole data represented by a horizontal cake here, okay? And ideally, median is going to cut this cake into half, right? The median is going to cut this into half. The middle part is called, we'll define this as a second quartile, right? Same as that. 1/2 of n+1 ranked data is the median, okay? And if you take the first half and you find the median again, okay, cut the first half into halves, that actually give you, oh, sorry for my art skills. I have very bad art skill. Okay? My son and daughter draw much better than I do. So anyway, bear with me. I'm sorry. So that's why I don't use the blackboard. I don't use the whiteboard because I don't draw very well. But here, cut the middle. Q1. Okay. So it's middle of the middle. So how we define it? Well, naturally, half again. So it's 1/4 of n+1. Okay. And we have another one. Cut again. Half of the second half is Q3. Okay. And if you look at Excel, function later, we will see they call the minimum number Q0. And the biggest number is Q5. Okay. And that means range is Q5 minus Q0. Okay. And we'll define immediately now the interquartile range is Q3 minus Q1. Okay. Let me say it again. Q1 up to Q5 is called range.
Where's
Sorry, Q.
where's Q?
Oh, sorry, it's Q. Sorry. Very good. It's Q4. Yeah. Sorry. Q4. Yeah. Q4 minus Q0 is called range. Okay. This is a Excel function later we will see. Okay. And if you take a difference between Q1 and Q3, it's called IQR. Okay. It's IQR. Okay. And you can see, looking at the 25% to 75%, the difference, because the data is more spread, then you expect the IQR is larger, smaller. Okay. And the good thing about this is you ignore the outlier, right? Look at the middle part of data. You drop the top part and the bottom part and look at how they're different. Is that clear? Good. So the only thing that complicates this is how do we define Q1 and Q3, right? We know that Q2 is already slightly little bit weird, right? When it's even number of observation is already weird. Odd number, there's no problem. Even is no problem, right? And when n+1/4, everything is integer, there's no problem, right? When they're not integer, how do you do about it? Right? And okay, IQR is very simple. Q3 minus Q1, as I said. As I have mentioned, how to define Q1 and Q3 is ambiguous. If you look at Excel, there are 2 different ways. If you use our software, there are 9 different ways to define it. And in the literature, I think there's more than 20 ways to define it. There are different ways to define it. Okay. So what I'm going to do is to tell you one way that I think is easier to understand. Okay. And I'll also tell you how you might have done in your high school. Okay. So that is the graph for the range and IQR already there. So I'm not going to repeat that one. So there are 3 methods. I don't think I have time today to go to the number 3, which is based on linear interpolation. I'll tell you how we do 1 and 2. Okay. 1 and 2 is very direct. It's based on median, and median. Okay. We found 3 median. Okay. And the 1 and 2, the difference is only whether we keep the median in our data. Okay. The first one is way is we do the median first, figure out what's first half or second half. We keep the median data, and we find the median first half, the second half. That is the idea. Okay. It's very difficult to explain, but it's easy to see the example how it works. Okay. Let's example. 1, 2, 3, 4, 5. Okay. 5 numbers. Median is exactly in the middle, number 3. Okay. So in the method 1, the median itself remain in the data set. Okay. So that means that the first half is 1, 2, 3, right? And 1, 2, 3, the median is just exactly 2. Done. And second half is 3, 4, 5, right? The second half is 3, 4, 5, right? The first half is 1, 2, 3, right? The second half is 3, 4, 5, right here. Okay. And the median is 4, right? Because in the middle. Okay. So Q3 minus Q1 is 4 minus 2. It's 2. Is that clear? What is the method 1 doing? So it is, I think it's taught, this is taught in the US system. If from US, this is what you learn. The other one I think is taught in UK system. I forgot what I learned when I was a high school student. The other way around is method 2 is the median will be excluded from the first half and second half. Okay. So in that case, it's 1 and 2. The median is 1.5, average of 2, right? In this case, 4 and 5, the average is 4.5 because 4 and 5, average of 4 and 5 or 4 and 5. And the IQR will be just the difference. So you can see these two methods will give different results. So as I said, there are at least 20, at least 10 IQR because there are at least 10 methods to define quantile. Okay, that means that you have to be very careful. You know what kind of quantile you're using. Okay, when you look at our software or Excel, there were different ways. You have to make sure that you use the right one, and none of these actually used in the software. Okay, so that's why I need to teach the next one in the next class. But before we do it, we give another example before we go quickly. If we have 1, 2, 3, 4, 5, 6, okay, the median is actually 3.5, right? 3.5 because it's only the average of the third and the fourth, right? Because 6 plus 1 is 7, 7 divided by 2 is 3.5. So the first half is 3.5, second half is 4, 5, 6. So the median of the first half is 2, right? The median second half is 5. So the IQR is 3. Okay. As far as this goes, the second method gives the same answer because the median is not in data, so there's no problem. Okay. So these two methods give the same answer. But as you see, this is different from the third method we will introduce. And you ask me which one we're using. I recommend use the number 3 method because this is what Excel gives you and what I'll give you as well. Okay. So I will see you on next Wednesday, same place. Friday, no class, just to make sure. Okay. See you. If you have a question, you can ask. I'll stay behind for a few minutes.